Hello, hello. We're still on 3.2. We're still talking about domain and range. And the last example we worked yesterday was example 4. And it had us find the domain of a square root function. And our function was 7 minus x. And so I need someone to explain to me the restriction we have when taking a square root or an even root. Hello, welcome to Algebra 2. Can't take an even root of a negative number. Okay, cannot take an even, because that's not a real number, right? You could, if you were going to use the complex number system and we were dealing with imaginary stuff, you could, right? I won't say that we can't, but in the real number system, that number doesn't exist. Are y'all with me? Yeah. Okay, so I can't take an even root of negative numbers. So, in order to graph this thing and to understand what its domain might be, we have to set the radicand, which is this argument under the radical sign. We have to just make sure that that thing is positive. Okay? And in order to make sure that that argument is positive, well, what kind of numbers are positive? Numbers that are, okay, real, yes, but there are real negative numbers. Bigger than 0. Numbers that are bigger than 0 are positive numbers. What about 0? Is 0 negative? Okay, so 0, I don't know that it is, we could classify it as positive, but we can say that it's non-negative. It's kind of neutral. Yeah, it says, can you drive a stick shift? See? All right. So what we're going to do here is we're going to set this argument greater than or equal to 0. And that says, hey, this is protected under this domain. This radicand can't be less than that. Okay, and you just solve it for x, which we did yesterday. We subtracted 7 from both sides. We got negative x to be greater than or equal to negative 7. We changed the sign by dividing by negative 1. We got positive x is now less than or equal to 7. And that's the restriction. That's the domain of this function. X has got to be less than 7 or equal to. Because if it's equal to 7 and I have 7 minus 7, I get 0. And the square root of 0 is 0. So that works. The other way that we would represent this is to say x is all the numbers up until 7. So the domain goes from negative infinity to positive infinity. And we said 7 works. So what kind of bracket do we put on this 7? Square bracket, right? And what kind of bracket do we put on the negative infinity? Okay. So that's a tiny little recap of the last 10 minutes of class yesterday, because I think most of you were sleeping by that point. So I just want to start over. We're not calling out Marcus, but I'm just saying, I think that we were mostly dead asleep by that point, and so it wasn't going so well. So I want to open today by reviewing that, and then by looking at a try it that goes with it. Okay, so there's you a chance to find the domain of this function. This is the domain of square root 5 plus 2x. Domain of 5 plus 2x. So what would you do? Yeah, set the domain, or set the radicand, 5 plus 2x, greater than or equal to 0. And then, minus 5. So this function is alive and well as long as x is greater than or equal to negative 5 halves. As long as we are inputting something greater than or equal to negative 5 halves, life is good. Could I put in there negative 3? That breaks it. Negative 3 is going to be less than negative 5 halves. That would be negative 6 halves, which is the other way. Right? Could I put in there negative 1? Yes. That's greater than negative 5 halves. So what's the domain in interval notation? The bracket things? Uh-huh. So x has got to be greater than negative 5 halves. So what's the lowest x could be? Negative 5 halves is the lowest end. And x is going to get to be anything greater than that. So it could go all the way up to what? See? You see how that's different than the other one that you just had? Where we had the negative 7. I don't know what's just happening to my screen right now. Anybody else intimidated by all of that? That's a lot. I don't know. I'm just going to move on. So we go from negative 5 halves to positive infinity. Square bracket, because x is greater than or equal to. Mm-hmm. Mm-hmm. Can I borrow your pencil right quick? Thanks. I got a problem over here. Oh, it's mine? Well, thank you for sharing my pencil with me. I got a typo on my notes over here, so I've got to fix it real quick. I changed my sign, but I didn't divide by a negative, so my notes are wrong. Now, catch. Thanks. All right, now let's start talking. So those were kind of looking at different equations. This is going to be imagining pictures, imagining graphs. So if I'm looking at a graph, okay, which you can see here, the domain measures everything from least to greatest in the left and right direction. Can you tell that? Look at the picture. Can you see it? Domain on this particular function is going to start where? Negative 5. That's the lowest x value that's touched here. Negative 5 to what? And it's crucial that you can see the bottom half of that. To infinity. See this arrow? That indicates that it's going to continue getting wider and wider and wider as it goes. So the domain here is going to be written from negative 5 to positive infinity. Does it touch at negative 5? It's a closed-in circle. So that's going to be indicated with a square bracket. What about does it ever touch infinity? So just parentheses. Are we good with that one? It wouldn't hurt. You don't have to. I mean, kind of sketch it. You don't have to. Just know what's happening here. Range is going to go from bottom to top. Bottom to top. We always measure range from least to greatest. So what's the bottommost value on this function? Negative. See the arrow? Where does it get to go? Negative infinity. This can go all the way down to negative infinity. What's the top of this function? So the highest number that it could possibly touch is going to be 5. Does it touch at 5? Yes. Square bracket. Okay, so domain left to right. Range bottom to top. Any questions on that? No? Say it again. That's pretty good for you? Okay. So this next image is going to be example 6. And it says, find the domain of the and range of the function whose graph is shown. So you're going to have some of these in your homework. If I were you, I would draw this picture right now on your paper. This is example 6. Did you get it drawn? I used to teach this, and we would do an assignment that had all these little graphs on them like this. And I would give my kids 4 sticky notes. And their job was to cut into the picture on the left and the right and the up and the down. And they would kind of mark out the boundaries that this picture touched. Does that make sense? And so then they would kind of zoom in, and you could tell exactly where this graph was able to be. Okay? So imagine that we're doing that here. The domain is going to be left to right. Left to right. So what's the leftmost x value that this function is able to go to? -3. And look at the picture, which I just colored over, but you can tell that at -3, it's an open circle. So that's going to be noted by open parentheses. That means it goes to -3, but doesn't equal -3. What's the furthest right value that this function touches? 1. And look at the dot at 1. Closed. Square bracket. Okay. Range, we do the same thing. We just go bottom to top. So what's the bottommost function? Or bottommost value? -4 with a square bracket. And then it maxes out at what y value? 0. And does it touch at 0? You see? Not hard. Read the domain and range from the function from the table. From the picture. Could the domain and range be the same? That's possible. It's possible. Okay, so next we're going to look at how this domain and range business applies to the toolkit functions. And I think it would be handy if you would draw them quickly as we put them up on the board. Okay, and we'll just talk out them individually one at a time. This is what? You remember what this one's called? The constant function. It's a horizontal line located at y equals whatever that number is. So the question is, how far left and right does this function go? So for the constant function, your domain is always going to be -infinity to positive infinity. There's no reason that this thing breaks. What's the range of this function? Whatever that constant number is. Y is only that value. So let's say this is y equals 2. Well, then my range is at 2. Pretty straightforward. That's the only output value that exists. Input could be anything, but every time I output, I'm going to output that same number. Okay, moving on. What's this one called? The identity function, okay? Or a linear parent function. This is the function y equals x. Y equals x. How far left does this function go? Infinity, -infinity, right? This is going to get forever and ever and ever to the left. It's going to keep on going, getting wider and wider and wider. And to the right, how far does this function go? Positive infinity. No restrictions here. And your range is exactly the same. It goes from -infinity, so it's going to continue to go down, 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 down. And on the right side, it's going to continue to go up, 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 up to positive infinity. It's pushing left and right forever and ever. Questions there? Did you get it down? How about these? What's this top one called? Absolute value function. Absolute value. Now, Think about it. This one is able to have any input. Any input. It can go forever and ever left and right. So its domain is going to be all real numbers. It's going to stretch left and right forever. If I extend that graph, those branches just get wider. But it has a restriction based on its range. It's always positive. Distance is always positive, right? So unless I transform it somehow, this thing is always going to be above the x-axis. If I put in -7, what's the output of -7? 7, right? So it's positive. So my range is going to go from bottom, which is 0, to infinity. 0 to infinity. That's as low as it's going to get to go. Not going to dip below the x-axis unless we move it somehow within the function. F of x equals the absolute value of x. Yeah, that's your absolute value function. Good? Okay. It goes always left and right, so all real numbers, but it stops at 0 on the bottom. 0 to positive infinity. This one behaves similarly. This is the quadratic function. F of x equals x squared. It behaves a lot the same way. I'll just draw you a little parabola. It continues to get wider. Increases or decreases without bound. It goes forever and ever left and right. However, it has a bottom. It bounces. So my range is indicated as going from bottom, 0, to top, positive infinity. Good? Okay. How about this one? Anybody remember what this one is? Cubic. F of x equals x cubed. And it goes forever and ever right and forever and ever left. Feels like it gets wider and wider. So my domain is all real numbers. But it also goes forever and ever down and forever and ever up. So the range is all real numbers. This one behaves very similarly to f of x equals x, the identity function. You getting good at this? This is good for you? Mm-hmm. Did you already learn this before?
Not the names in English are weird.
The names in English are weird? You know this stuff, domain and range for them?
Not the names, but yeah, the things.
The things you do know? That's good. We good on that one? The cubic function? Do you need me to keep that up there for just a second? Or are we good? Good? Okay. How about this one? What's this one called? Oh. Y'all know this one? Reciprocal function. I don't know why it's... Now, look. This is getting better. There's our reciprocal function. This one has restrictions. Why? What can I not do? When I'm dividing, I cannot divide by 0. So notice that this function is broken at 0. We talked about this yesterday. My domain goes from negative infinity to 0. It stops. It goes from 0 to positive infinity. That's because right here, if I try to divide by 0, the function is undefined at x equals 0. The range is undefined at 0 as well, because if I can't input 0, then I'm not going to output anything at that value. Questions? No? Okay, let's keep going. This one. Yep, you got the reciprocal squared function. Its domain is very similar. But talk to me about its range. Always going to be above the x-axis on this one. Why? Because x is getting squared. So my output values are going to be located above the above the x-axis. Even if they're negative inputs, when they get squared, they become positive outputs. Y'all, we're nearly done with this. I just want you to have these information pieces down on paper. Mm-hmm. This f of x equals 1 over x squared. Yeah, 1 over x squared. Still can't divide by 0. Still have a broken function right there. Okay. And the bottom one here. Whoa, sorry. Whoa. This is the square root function. So f of x equals the square root of x. Notice that there's nothing to the left. It has to start at 0. Why? Because I can't, cannot even root 0. I cannot even root a negative number. So this one is bound on the left side at 0. Nothing over here. So this one goes from 0 to infinity. Consequently, the range also goes from 0 to infinity, because if I take the square root of 0, I start at 0, and then it gets bigger. Cool beans? The last one was the reciprocal squared. Reciprocal squared function. Okay? Guys, you did a great job of memorizing those functions. Really good job. How about this one? I think this may be the last one that's one of your toolkit functions. What is this called? The cubed root. Does the cubed root function have any restrictions? Look at that domain and range. This is y equals the cubed root of x. Does it have any restrictions? Are you noticing any restrictions? It doesn't stop at 0. Why not? Because I can take the cube root of a negative number. I can take the odd root of a negative number. So no restrictions here. This goes from negative infinity to positive infinity in both domain and range. This is your cubed root function. Okay, so your even roots are going to be bound by negative numbers, but your cube roots are not. Okay, so there's really good how-to information down here at the bottom, how to find the formula or how to determine the domain and range. Number 1, exclude any input value that make you divide by 0. We know we can't divide by 0. Number 2, exclude any input value that make you have non-real or undefined outputs. That's going to be when you're trying to root a negative number. Those are the 2 restrictions that we have talked about. Can't divide by 0, can't take the even root of a negative number. Otherwise, we're okay. Deal? Ready to practice some problems? Say, yeah, we're good. Ready to practice problems. We're excited about this. Okay. So here's example 8. And really, we shouldn't have to do a whole lot of math here. Really, if you know your toolkit functions and you understand what we just did, we should be able to tell our domain and range. So example 8 says find the domain and range using your toolkit functions. This is the function, f of x equals 2x cubed minus x. What's its domain? It's a cubic. So domain is going to be negative infinity to positive infinity. What does this guy look like? Something like that. F of x equals 2x cubed minus x. So you should recognize that as a cubic. You should be able to reference your toolkit function, domain and range. You should know this goes from negative infinity to positive infinity in domain. What about range? What does it do? Negative infinity to positive infinity. Is that better? Good? Okay. Example 9. What kind of function is this on example 9? Reciprocal? It's not reciprocal squared, it's reciprocal. Cannot do what when I'm dealing with a reciprocal? Cannot divide by 0. So to find our domain, we set the denominator equal to 0 and we exclude that number. What number? -1. X cannot be -1. So what's my domain here? Negative infinity to -1 with, can it be -1? 2 over x plus 1, yes. It can't be -1. So what kind of bracket do I put here? Parentheses. Parentheses, good. To what? Then I'm going to pick back up and I'm going to go -1 to positive infinity. Good. Good, good.
Is this for the homework?
Mm-hmm.
Is that like the unit?
Union. So negative infinity to -1 and then -1 to positive infinity. Okay, now if my denominator can't be 0, then my function is never going to equal 0. So the range here is going to go from negative infinity to 0. And then 0 to positive infinity. What I'm saying is if I say that my input will never make a 0 on the bottom, then my function itself will never equal 0. Okay. How about example 10? Are y'all ready for it? Yeah, this is a square root function. Find the domain and range of f of x equals 2 times the square root of x plus 4. And what's the rule on even roots? The radicand can't be negative. So we take the radicand part, x plus 4, and we set that greater than or equal to 0. Good. And so what? How do I solve? Subtract 4 from both sides. So x must be greater than or equal to -4. How do I say that in interval notation? X is greater than or equal to -4. And remember, we go from left to right. So what's the leftmost point on this graph? -4. X is greater than or equal to -4. So it's going to get to go from -4 to what? To positive infinity. Is it going to touch at -4? Yes. Is it going to touch at infinity? Now, how do you find your range given that domain? Well, you know it's going to start when x equals -4. So your range is going to be determined by finding what is f of -4, which is going to be 2 times -4 plus 4. You're inputting -4 here. What happens when I put -4 in there? 0. 2 times 0 is 0. So the bottom of this function is 0. So this one's going to go from 0 to positive infinity. Good job, Mason. 0 to positive infinity. Is it going to touch at 0? Yes, because we said that's what we output when x is input -4. What do you think? Lost?
That one is a little bit longer, but it makes it count more difficult.
Okay. You want to do a try it for that? Just one more example, and that'll get you through your homework. Yeah. Okay. So here's the try it that goes with the domain and range business. It says f of x is equal to -2 minus x. And it wants to know what's the domain and what's the range. So to find the domain on an even root, what do we do?
Greater than 0.
Set the radicand greater than or equal to 0. Very good. And so now what?
Minus 2.
-2 from both sides. Negative x is greater than or equal to -2.
Yeah, flip the sign.
And flip the sign. Good.
X less than or equal to 2.
Perfect. So now how do we put that in interval notation? X is everything less than or equal to 2. Negative infinity to 2. Square bracket on 2. Open bracket on negative infinity. That's saying I go up to 2, but I stop there. And now my range is going to be determined by that input at 2. And I know that I'm going to go from the bottom up, right? So let's see, what is f of 2? That's going to be negative square root 2 minus 2. Negative square root 0, which is just 0. Okay, and I can only input values that are less than 2. So that 0 is going to be actually my maximum value. So the range is going to be going negative infinity to 0. Graphically, this guy looks like this. Nope. I think he looks like this. X is everything to the left of of 2. And the range goes from negative infinity to 0. Does that help you get stuff for your homework? Okay. So you have a 3.2 homework assignment. It's posted in Canvas. We'll finish section 3.2 tomorrow. I feel like that's enough to overload the boat today. This finishes 3.2 part 1. That's the homework assignment.
When the